All right, ladies and gentlemen, today we're going to go over panels. Panels part 2. All right. Now, everybody who lives in a house, they go look on the outside of the house, they will see a panel on the side of their house. All right. It could be in the wall or hanging on the outside of the wall. And I'll usually have a glass, like a little glass bowl with a meter in it, or have a bunch of numbers across, a bunch of numbers in here. And then if your house can be fed from the utility company. Now in your area, it's either going to be Edison or PG&E, but they call it the utility company. So it'll either, like, let's say this is the ground, all right? And this is your picking house right here, So the ground would be up higher. So there's two ways that these can be fed. There are only two ways. You're going to come in from underground, all right? Yeah, let's make this more what I'm going to show you here in a second. You can come in from underground like this. Your power can, it'll be a conduit, have wires in it, and they'll go up in here and hook to your meter like so, okay? That's one way. The other way is, if it doesn't come from underground, it can go overhead. And there'll be a little weatherhead here, like so. And it'll look something like this. And you have wires like this. And they'll go over to some kind of pole, have a little transformer on it. Look like that. That's supposed to be a telephone pole right there. That doesn't go in your house. That's just out somewhere else. Anyway, you get the idea. Come from the utility pole, you'll have a transformer on it, it'll come over, feed your weatherhead, and your wires will come down and hook onto like that. That is if you don't have the underground. So really, services, now since we're talking about services, this part right here, the glass part, that is a meter, okay? That's your electrical meter. This whole thing is called this is your service. The first point of connection at a building or anywhere is called the service. The meter right here is what measures how much power you use, all right? It doesn't measure in amps, it doesn't measure in volts, it measures in watts, okay? So remember, watts equals volts times amps. But if you just use a certain amount of watts, it doesn't add them up. It measures how many watts you use per hour. And since people use a lot, it's kilowatts. So it'll really be measured in kilowatts. And it'll be kilowatt hours, okay? So how many kilowatts you use per hour is what you're going to be charged for. Normally it's about 12, I think its average is about 12 cents a kilowatt right nowadays. So your service, first point of connection, where utility comes in, your utility power comes in, either comes in overhead, It either comes in underground. All right. This is called the service. Your meter is that little glass bowl on there, and all that does is measure how much power. Remember, watts equals power. That's how much power you're using. It's measured in kilowatts, kilowatt hours, okay? And like I said, the going rate is about 12 cents a kilowatt hour. So you can look at it on that meter and see how much power you're using. So let's look at some of this stuff. So right here, now this isn't the same kind of meter you have on the outside of your house. I mean, it is, but the ones on the outside of your house are all digital now. This is an analog one. So it has a little wheel in there and spins around. And then these little numbers here tell you how many, actually this is not kilo, this is just plain old watts. Tells you how many watts you've used, all right? So basically what you got is you have your power comes in through your meter. Power comes in to here, goes through your meter, comes back out here and goes to your panel, all right? So it measures what comes through. Now, typical residential house will be 120, 240, which means it'll be 2 circuits of 120. So this will be 1 circuit of 120, comes in, goes through your meter, comes out. This is your other circuit of 120, comes in, goes through your meter, and then goes back out. So, and then those together equals 240 because they're opposite phases. Anyway, long story short, that is a electrical meter, not your service. Your service is the whole thing. So let's show you. Now services, since we're talking about, we talked about wire the other day. You know, the most important thing about wire is what size you get for the amperage that you're going to need. I mean, obviously, you need to know the covering up, but the most important thing is the size. Now, the voltage on wire doesn't really matter that much because all typical construction wire made for electrical construction is rated for 600 volts. So remember, for residential, we have 120, 240 volts, and then your commercial and industrial, they can have the same thing, but they also have 277, 480. So since that's under 600, you can use the same kind of wire for both. But when you go get a meter, you can't do that. You have to make sure that it is the right voltage. So if you look at this, it will tell you right there. This is good for 120, 240. So that's important. When you get a meter, you got to get the right voltage. Like I said, for wire, unless you're doing high voltage or some kind of weird stuff, it doesn't matter because all the wire's rated for 600. So you can see this is rated for 100 amps right here. So I don't know about the real percentage. I'm just generalizing, but probably 90% of the houses have 100 amp service. This is the most common service for a house. It can be 100 amps. Now, if you're a real rich person, big, ginormous 5,000, 10,000 square foot house, you're going to have a bigger service. You could have a 200 amp, 400 amp. A lot of the bigger houses have 200 amp, but just your average house, this is the kind of panel you would get, okay? Would be 100 amps. The remember the A stands for amps right here. So you should know that. Uh-oh. Somebody coming in, coming out. What are we doing here? Doggone it. I wish people would just show up on time. Oh, he must have got kicked out. All right. So this tells you how many circuits you can put in there. It tells you have 16 spaces to put breakers, but you can put 24 circuits. You can put doubles and all kinds of stuff. it gives you an idea about how many circuits you can run out of this panel. But the main thing, well, that's important, but the main thing is you get the right amperage. And like I said, 100 amp panel is the most common size panel for just a typical house. So you're going to want to pay attention to your amperage, number one. You're going to want to pay attention to how many circuits you're going to need. Most of them will cover anything. I mean, if you need a lot of circuits, then you have to like look for more of a specialty panel. This is a good average panel right here. So you need to look, the main thing is your amperage. You need to make sure your voltage is right. And the other thing is right here, outdoor. So you need to make sure that if this is going outdoors, which probably 99% of services are outdoors because the utility company has to be able to get to them. That means they have to be weatherproof. They have to be able to get rained on and dust, and they have to be out in a dirty, wet environment and not let water and dirt inside and you know, short out and blow up. So if it's indoors, if it said indoor, you can only use it indoor, okay? If it just said indoor instead of outdoor, then you could only use that indoor, and I'll show you what the difference is by just looking at them. Now you can use an outdoor indoor. It doesn't matter because an outdoor has to be weatherproof. So you can put it inside, it'll just be fine. But you can't put the indoor outdoors because water will get it. Water, and the main thing is water. Can't have water getting in the electrical panel, obviously. So let's take a look at this. All right, so you notice you're talking about indoor, outdoor. You see how they have these the seals on the top and they got a little piece of rubber in there that keeps water from getting inside. Where you here on the bottom, since water doesn't run uphill, they have these, get these where you can see this. There you go. They got these knockouts. You know, you can knock these out. So these don't have to be sealed with a Myers hub or anything because, like I said, water doesn't run uphill. It wouldn't hurt if you wanted to go the extra mile, put a Myers hub on there, but depends where you're at. If it's going to get a bunch of water, like a sprinkler's going to be on it or something, yeah, I'd put a Myers hub connector. Anyway, so remember, told you guys about coming in from underground. So this panel would be on the side of your house, and this is, you could use this hole to go up overhead, and I got some overhead stuff I'll show you later. Or you could use this knockout to come in from underground. There you go. I get it, the glare on there just right. There you go, you can see it. So you can come in underground, you can come in overhead. So most panels are that way. It used to be back in the day, you had to pay closer attention to that, but you still should. You don't want to get a panel where you can only come in one side and then be stuck. You don't want an underground panel you can only come in from underground when you're using overhead. Anyway, you get the idea. So, but like I said, most of the new stuff there, you can come in either way. So, and the other thing is what makes this weatherproof. You see this little lip across it. It's like a little eave, like a house has an eave. You know, you get water or rain on here, it's just going to run off. But well, and they got the same thing here. They got little lips everywhere. But if it was just like this here, you know, this part here obviously is facing down. The water is going to run down. But if this cover here was just flat, water could get in there, and that would be an indoor. So you'd be able to tell an indoor panel from an outdoor panel just by looking at it. If it just had a flat cover that screwed on it and it didn't have this little lip, then you know it's only good for indoors. Okay, so here is your electrical meter. Okay, now you all seen these on the house, and remember these little deals. The power comes in through your meter, back out. Well, you can see right here, those little tabs go right in these sockets right here. So your power comes in from either the bottom or in from the top, hooks to these lugs. I'll show you those in a second. It goes through these, through your meter, and then it goes over to here. We'll take this apart and I'll show you. But these just basically push in, all right? Come on, baby, go in there. There we go. They just snap in like so. All right. Now, utility companies, they'll have a ring that goes around here with a big giant lock on it because they don't want you getting in here like stealing power. Like you could take your meter out like that, and you could just take like wire and you can go from there to there, you know, and you'd bypass your meter. Like you could hook, your power would still be going, but you wouldn't have a meter, so you wouldn't have to pay electricity. The problem with doing that is not only is it against the law, you can go to prison for like 1 to 5 years. And I think the fine is like $2,500, $2,500 or something. So what they do is they have a little ring. The old ones had a ring like this. The new ones have a big fancy ring. They're super hard to get in. Back in the day, they were just had these kind of rings. Had a ring like this. And what they would do, if you see this little hole right there, whoop, 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 they'll put a little piece of wire through there, a little piece of steel wire, braided wire, and they'll use a piece of lead, sorry. They'll look like this. Here's a perfect example of a seal. Right there. You see that little piece of lead? And then they have that wire goes through that little hole right there. It comes around and then they squish this lead on here. So there's no way that you're going to take this apart without cutting that wire. And even if you cut once you cut the wire, you can't put it back together. If you pull it out of the lead, it won't go back in. So this is a way where you can tell if somebody's been in here or not. Well, they'll do the same thing with this. Of course, they have these other rings, but they still put a seal on even those other rings. And you put this on here like so. Make sure I'm still on the camera here. Yeah. You put this on here like so. There we go. Snap it in there like so, and see it's closed. This won't come out. And then you put that little wire through that hole, and then you squeeze the lead on it. The utility company will. And that way they know if you've taken this meter out or not. Now, as an electrician, when you're wiring up a house, you are 100% allowed, in fact, you have to get in here and hook all this stuff up, especially if it's overhead. You have to, that's better. You know, if it's overhead, you'll have to put a conduit in here and bring your wires down. We'll do that next week. But long story short is, once the power is hooked up and the meter is in and they got their seals on, no one is allowed to be in here at all, except for the utility company. Again, 1 to 5 years in prison and $2,500 fine, I think, is a going deal. So if you notice, if you notice, there's a cover on the bottom here, has a little screw. Well, you go, oh, dang, I'll just flip this deal up, get in here, take this cover off, and then I can steal electricity that way. Well, look what they do with this little screw right here. They'll usually put a seal in this latch, but even the pick and screw, I mean, you'll have like 3 seals on this thing. If you look, even the screw, get it out where it focuses, even the screw has a little hole in it. You see that? And they'll put a seal through that screw and they'll hook it. Now, this particular screw, they don't have a good place to hook it. I guess they could hook it through the latch and then through the screw, but they can, that way they'll know if you ever even took this screw out or not. So again, I want to remind you, don't put the screw in your pocket. Don't throw it on the table. Don't throw it in the panel. If you want to go through life and never lose any screws, unless somebody steals them because they lost their screws, put the doggone screw back in the hole where it came out of. It will always be there. Trust me, that's my little pet peeve. I get a little OCD about that because I get tired of you guys all losing your screws all the time. If you notice, it says right here, get this, there we go. Oop, 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 oop. Do not break seals. Do not break seal. No fuses inside. So they're telling you, don't break any of these seals and get in there because you get in big trouble. You have to do it sometimes, but on your own. I mean, if you're an electrician, they might let you slide, you know, if you're working on a project. But if it's your own house, no. And you got no reason other than just to get in there to steal power, you're going to be in big trouble. The other thing is there's really no current protection on that except up at the transformer. So you could really get electrocuted bad. It's not like over here where the breaker would trip. All right, so bring this back down here. Get a little closer look. I think I like it better up here. That's Chihuahua Quattro Apaches. All right. So, right there, remember I said we had 240 coming in. You had 2 120 volt circuits out of phase with each other. So you got 120 here. So one wire will go here. The other hot wire, 120 volt hot wire will go here. And your ground and neutral will go here. Remember, your ground and your neutral only hook together at your service. So this is the only place they go together. All other panels, your grounds and your neutrals have to be separated. But right here, they have to be together. This is the beginning point, all right, at the service. So forgot to take the ring off. Oh, there's a couple screws right in here. We can take this cover off. Kind of get an idea. Let's back in here. So, as you can see, they got this side completely sealed off from this side. That's what this side is, the customer side. This is where all your breakers go on this, in this side right here. Okay. We'll open this up tomorrow and go through it on all the different parts. This is the customer side. You can do anything you want in there. Well, as long as it's the code. This is the utility side. And once the power's hooked up, you're no longer allowed in here. but you're allowed in here while things are getting built. But as soon as those seals go on, you're not. So your power comes in here. If you look behind here, there's these little bus bars. They come up to the top. Your power comes through here, through your meter, okay, out, and then there's a little bus bar, and you can see them. Get a closer shot. You can see them right back in here, okay? That takes power over to the customer side, up in here, all right? You kind of see those bus bars come through there. And they go to your main breaker right there. This is your main breaker. So you can see the sides all sealed off. So this is your utility side, and this is the customer side right here. Utility side where the meter is, and only the utility company can be in there. And this is the customer side. And this is your side where you have all your breakers and stuff. So anyway, that's pretty much all we're going to go over today. Like I said, this is just an introduction. We'll go over more like all the parts and everything later. But you guys get the idea. So you guys need to know right here for your test tomorrow. You have a service. The first point utility company hits your house is the service. The little round bowl is with the numbers in it is the meter. It measures power in kilowatt hours. All right. This meter, this service can be fed from underground or overhead. It could be on the outside of the wall, or it could be in the wall with just the front of it facing. So they call it flush mount or surface. This particular one is a surface panel. However, you could probably leave part of it stick out. It's kind of made for it. So remember, indoor, outdoor, overhead, underground. First point utility comes in is a service. This is your meter. Measures power in kilowatts. You have a utility side, which you're not allowed in once it's powered up, and you have a customer side, which is for you to run all your circuits. When buying a meter, you need to know what amperage you need. You need to know what voltage. So your house, all your houses are going to be 120, 240. Typical meter, a service for a house, going to be 100 amps. Could be 200 if it's a big house. Super mansion, 400. But anyway, I think that's about it. All right, gentlemen. Have a good day. Laters.